Welcome back, students. This week we are going to do torsion pendulum, and using this we are going to find out the rotational inertia of unknown body. So this is the setup we are going to use. This is the torsion pendulum. The whole setup is torsion pendulum. This guy is called the table, empty torsion table. This is the auxiliary body. This is experimental body 1, experimental body 2, experimental body 3. So using the setup, what we try to do is slowly twist it a bit and let it go. And from one particular position to the extreme, we start timing. Let's say we start here, and then we go for about 10 rotations. So that's 1, and then it goes back, comes back here, that's 2. In this way we do it for 10 rotations, and then we stop the clock and then find out what's the time. And then we also use this in the center of it and repeat the whole thing again to find out what's the time of oscillation for this combined body. So we are going to use this slide to find out for the auxiliary body what's the rotational inertia using this formula, which is the mass radius squared over 2, because it's a solid block. The reason we need this because we don't know K. So if we don't know K and we just know time, we can't really find out inertia. So we need to know K, or we need to eliminate K somehow. So what we do instead is we do it with a known inertia, which is the auxiliary body. So we bring it here, and then we find out for the empty torsion table, we find out the T naught, and then T plus auxiliary body, as you have seen previously when we add the auxiliary body and find out the time. Since we know this and we know this, we divide this by that. So we take a square first and then divide. So it becomes T squared at T, divide by T naught squared. So once you divide this thing with this part, it's going to end up having this, which is 1 plus IA over I naught. Then we make I naught the subject of the equation. It becomes IA, which we already know by calculation. And this is what we have measured. This is what we have measured. So as a result, we can find out what is the rotational inertia of the empty table. So once we know that, for any given unknown object, it becomes Ix equals to I naught and Txt, which is the unknown body plus the empty table, so which we can measure, and T naught we already found out earlier. So as a result, for any given unknown body, we can find out Ix using this formula.